GWAZNOMICS. I welcome you all, ladies and gentlemen, in the mighty name of Jesus Christ, to the debut production on GWAZNOMICS. This is a section of Gwaze tutorials which deals with various topics to do with economics, be it microeconomics or macroeconomics in nature. But the center of this production will be on teaching you consumer theory, which is a body of microeconomics that studies the behavior of consumers, how they optimize their decisions, okay, or how they go through their decisions in order to maximize utility. And the same decisions also affect the flow of money across the globe. Right, so that's just consumer theory in a nutshell, but there's more to that. And secondary to this would be to explore the properties of the convex demand curve, a very sensitive area in consumer theory, which I saw it necessary to occupy my debut production. Through experience, I've seen that this topic on properties of the convex demand curve does indeed give students a hard time. Right, so let's get started. By the end of this production, you must be in a position to distinguish a convex graph from a concave and linear graphs, define a demand curve, describe the behavior of price and quantity as exhibited by a convex demand curve, and deduce the fact that the total revenue for a convex demand curve is always constant for all bundles of price and quantity. So these objectives will be met throughout this production. Occupying the first part of the production will be to define some of the key terms and concepts. And one of them is convex. What do we mean when we say a graph is convex? Well, to illustrate or to establish that definition, I would like to make use of the vertical axis and the horizontal axis. So appearing on your screen is your vertical axis, and there is your horizontal axis. And the graph appearing just on your screen, the red graph, is the convex graph. That's how a convex graph looks like. It's quite different from its close cousin, the concave graph, which I'll just illustrate. So if you're to explore a concave graph, this is how it looks like, all right? As you can see, the convex graph bends towards the origin, whereas the concave graph bends away from the origin, okay? And graphs that are straight or that assume a straight character are known as linear graphs, all right? So these are the types of graphs that we deal with or we model in economics, all right? So that's a key property that you can use to distinguish a convex graph, which is this one, from a concave graph and other graphs which are linear, all right? If it's not the definition of it bending towards the origin, you can also make use of tangents, all right? The position in which tangents are related to the graph can also help us distinguish a convex graph from its other counterparts. So appearing on your screen is a tangent which is coming in contact with your graph. And just observe how the tangent rests on the underside of the graph or underneath the graph, all right? So that is another property of the convex graph, that its tangent rests underneath it. Whether it's positioned here, or let's just throw another one here. Wherever you're going to place your tangent, the tangents to a convex graph lie underneath it. It's different from tangents of a concave graph, which lie above it. So whether you to place your tangent here or you to place your tangent there, right? Whichever way you place it, just roughly illustrate it, okay? So wherever we're going to place our tangents on our concave graph, it always lies above the graph. Linear graphs, they assume their own tangent, or they define their own tangent, okay? Continuing with the definition of key terms, or the definition of key concepts, we have another key concept to be defined, which is now what is it that we call the demand curve? Well, a demand curve is a graphical model illustrating the relationship between the quantity of a given good or service consumers are willing and able to buy, and the market price prevailing within a given time horizon, be it a day, a week, depending on which time horizon we're looking at. I know this sounds like a mouthful, but I want you to take notice of two key aspects that are defined within the demand curve. So the demand curve is just a graphical model, all right? Our models can assume many characters. They can be graphical in nature. They can assume a formula kind of character. There are so many ways of expressing a model. But as for a demand curve, it's actually a graph, all right, which illustrates the relationship between the quantity, right? So we've got two variables that we are describing this relationship. There's quantity and there's also price. Those are the key concepts which you have to take notice of in this definition of demand curve. So which quantity are we studying? Well, this is a quantity of goods and services which consumers are willing, not just willing, but they also have the capacity to buy those goods and services. So it's not just a matter of wishing to buy something, but you should have the monetary capacity to back up that will or that power, right? Maybe you might be asking, what's the difference between a good and a service? Well, let me just illustrate the distinction. When we're looking at goods, we might be talking about things like cars or even food, right? So in a nutshell, goods are those kind of commodities whereby there is 100% transfer of the ownership from the producer to the consumer, right? So goods, you can detach them from the producer and transfer them to the consumer. So when you buy your car and it's an outright purchase, it becomes yours, okay? That car has been transferred from being the property of maybe Benz to become the property of you, the consumer, whoever you are. When you buy your hamburger from, let's say, McDonald's, it no longer become McDonald's commodity, but it's now transferred to you, right? So that's the key property or concept of a good. There has to be that transfer of ownership from the producer to the consumer, right? How about service? Well, we can start by exploring some of the specimen of services. It could be, say, train logistics. So let's say business is hiring locomotive transport to have its consignments delivered from one part of the country to another. That is a service that it's actually hiring. Okay. It could be communication. All right. So this is one of the most popular forms of services today. Cell phones have made up a very, very significant part of our day-to-day services, especially in Zimbabwe, where the ICT industry is booming. It's one of the largest growing industries in Zimbabwe because of the cell phone boom, right? And another thing about cell phones is that the cell phone itself is good because you have acquired its full ownership. but the service comes to the telecommunication network which you're hiring in order to get onto your social network platforms or just to have the general form of communication, all right? So some goods carry both aspects of a good and a service. Okay, some commodities are both a good and a service. Like a cell phone, it embodies a good, it embodies a service. Even education is a very important form of service. Now, the difference between goods and services is that, unlike goods, you can never divorce the producer and the commodity. Okay, you can never divorce the commodity from its producer. When you're supposed to consume a service, there has to be the producer. You can never own that service 100%. You always have to refer back to the producer whenever you want to consume services. So if it's education, you always have to go back to your teacher in order to acquire that education. If it's the train logistics, then you always have to go back to that parastate or that company that's offering those locomotion logistics. If it's telecommunications, you also have to go back to that company that is whose line which you're hiring. Okay, so that's just the definition of goods and services in a nutshell. All right. So we have just explored the first part of our relationship, the quantity of goods and services consumers are willing and able to buy. The other part of the relationship is the market price, right? The monetary value you are willing to compensate in order to hire that service or buy that good. Unlike some economies or traditional economies where the value of goods and services was expressed in kind. So if you wanted to buy or you wanted to acquire, let's say, meat before money came into existence, you actually had to exchange it with another good or services. So it was goods and services valued in terms of goods and services or in kind. But today's economy values goods and services using money. So most economies today have become monetary economies. So you exchange money in return for goods and services. So suppose you want to buy your airtime for your cell phone, okay? And in Zimbabwe, the market price for airtime is actually $1. All right. So that dollar is actually the market price for airtime in Zimbabwe, right? So that particular monetary value is prevailing within a given time horizon, right? So this relationship is actually studied under a given time horizon. You can be studying it during the day or over a week or even over a year. But in most markets, changes in quantity and price are usually observed on a frequent basis, hourly basis, and I think the longest period would be a day. So it's actually the day time horizon which we are interested in knowing how quantity and price are changing in any given market. It can be the market for cars, the market for hamburgers, for hot dogs, even for train logistics, education, and communication. So whichever markets we are looking at, we are always interested in knowing how much goods and services are flowing to that market, how much consumers are demanding, and also the market price. Now that we have set the ground by defining the key terms, I would like to progress with this production by consolidating the two concepts I just defined. Number one, the demand curve, and the other one being the convex graph. So I would like to study the properties of the convex demand curve. All right. So that is going to occupy the heading of this part of the production, the convex demand curve. Appearing on our screen as before is the vertical axis accompanied by the horizontal axis. And it's traditional in economics to label the price on the vertical axis, which I don't have the time to explain why. and to also label the quantity of a certain good, which in this case is bananas, on the horizontal axis. So as I defined before that, demand illustrates the relationship between price and quantity. And for this given hypothetical market, I'm going to study the relationship between the price of bananas per kg and the quantity of bananas per kg. The time horizon which I've actually picked out is the day. So how many bananas are demanded by consumers in any given day? All right. So coming onto our screen is Mr. Banana. You can just say hello to Mr. Banana as he or she entertains us throughout this part of the production. Appearing on the screen once again is a convex graph. In this case, it will be the convex demand curve, which I'll label as DD. All right. I want you to notice something very interesting. This demand curve, like most demand curves, has a downward sloping character, which means that price and quantity are negatively related, right? Price and quantity are negatively related. What does that mean? Well, to express it further, if one of the variables is to increase, the other variable is to decrease. So suppose if the price of bananas is to increase, that is going to negatively affect the quantity of bananas traded per day. Okay? To illustrate that more, I would like to put in some numerical labels onto the screen. So suppose we have got a price of $1 per kg for bananas, and the quantity of bananas demanded is 100,000. All right? And I would just like to establish that point as being point A. All right? So when you've got a price of $1 and quantity of 100,000, the bundle makes up point A. So that's the bundle of price and quantity makes up your point A. And filling up the area defined within this bundle is a blue color, which I've just decided to illustrate a very important concept in economics. So this blue area actually has an economic interpretation, which I'll develop as follows. The assumption is that these lines are perpendicular to each other, so it means they meet at 90 degrees. Not only that, but so that makes right angles right there. Okay. Not only that, but opposite sides are equal in length. So my question to you, ladies and gentlemen, is that does this model or this shape that I've just defined, does it sound familiar to you? Yes, it actually is a rectangle. So what I would like to do is to calculate the area of this rectangle, right? So let me just do it roughly over here. So the area of this rectangle, right? The area of this rectangle is equal to the product between the length and the width. If we were to refer back to this diagram, I think you can agree with me that the longest side, pardoning the scale, of course, $1 is far much smaller than 100,000. But if you just take up the absolute length, which corresponds to $1, $1 being the longest side is our price. So the length is assumed in this particular case Our length is assumed by the price, and the width, being the shorter side right here, is assumed by the quantity. So the area, if we're to now define it in terms of the economic setup of this model, the area of this rectangle is given by the product between price and quantity. In this case, our price at bundle A assumes the value of $1 per kg. Okay. Now, this $1 is going to be multiplying a quantity of 100,000 kgs. So 100,000 in scientific form would be 10 to the power 5 kgs. Let's simplify out this calculation. Kgs will collapse with kgs, and $1 multiplying 100,000 will give us $100,000. So that's actually $100,000 for you right there, which I'll express in short as 10 to the power 5 once again. Okay. Now, ladies and gentlemen, we've just found out that this blue area actually has a monetary value. Okay. And that monetary value is given a special name in economics. Okay. So that special name, which I'm placing in parentheses, is termed total expenditure. In acronym form, total expenditure. Why do I call this the total expenditure? Because in this hypothetical banana market, this $100,000 represents the total money spent by consumers. Okay? If, or in other words, if I'm to redefine it clearly, this $100,000 represents the total amount of money consumers are willing and able to spend in the banana market, given a price of $1, okay, and a quantity of 100,000. All right. So they're not yet buying because we have not yet put supply into the picture. All right. If we were to put the supply curve, this will not only become what they are willing and able to buy, but it now matures into what they're actually buying out of that market. So if you are taking demand in isolation, know that you have to use the words like willingness and are able to buy. Okay. But once you consolidate supply and demand into the picture, it then matures into how much they actually buy from the market. Right. So this is the total amount expended or spent in the market. If we're to consider the interpretation of the same area in the context of supply or producer theorem, we would call it total revenue. Okay, so it depends on which branch of microeconomics you are coming from. If it is the consumer theory aspect of microeconomics, this area is defined as total expenditure because we are looking at how much consumers are willing to buy in that market. But if we were to move over to the producer side of the market, it's how much producers are able to earn from that particular bundle of price and quantity. So it's no longer the expenditure, but it's the revenue that is coming back to producers. How much revenue they are collecting as a group. All right. So it might be 100,000 producers in that market, but to consolidate all their revenue, how much revenue are they making in total? Okay, so I think I've spent enough time explaining that. This must be much more clear to you. Right. Now I'd like to establish another band of price and quantity, just to show you how maybe say a fall in price is accompanied with an expansion or an increase in quantity demanded. And this is concurrent with how the demand curve is downward sloping in nature. Okay. In other productions, I'll be exploring other types of demand curves, like for example, the marginal revenue product demand curve, marginal revenue product of labor demand curve, or the MRPL curve, which is concave in nature. Some other demand curves are linear, right? So it depends on which type of demand curve you are exploring. But as for this production, I'm restricting my focus on the convex demand curve. All right? Okay. So here we go, as we establish the other band of price and quantity. Now, suppose price falls to 40 cents per kg. How is this going to affect the quantity demanded? Well, as you can see, your quantity of bananas demanded expands to 250,000 bananas demanded per day. So as price falls, holding other things constant, we see that consumers are willing to buy more bananas, maybe for the fact that they become more cheaper, and for that very fact alone, consumers will be able to buy more of that commodity. All right. As for this bundle, I'll label it as bundle B. And the area bounded within this bundle, I'll shade it out in red. As I previously did for the blue area, I'll define the same properties for the red area. So once again, I assume that these lines are perpendicular at the point of intersection. Hence, we have another rectangle that is defined. Opposite edges are equal, as we did before. All right. Hence, for that very aspect, we have another rectangle. Now, you can always pause the video and explore the total expenditure defined by this red area. How much is the value of the total expenditure for this particular band of price and quantity? Okay, so you can pause the video and follow throughout this format. If you are ready, you can come back and resume to see whether your answer tallies with mine. Welcome back. I assume that you found, or you went through finding the product between 40 cents per kg and 250,000 kgs. So you should end up with $250,000. Right, so $250,000 is your total expenditure. Yes or no? Actually, that's wrong. I wanted to test whether you got it right. So I usually like to trick my students to see whether they did well. Actually, it's 100,000. Yeah. So if you're smart enough to get 100,000, that's correct. Okay. So don't be like the other student who got 250,000. Okay. So your $100,000 is actually the monetary value of this red area. Okay. Can you see something interesting about the two rectangles which give us the total expenditure at each bundle? Your total expenditure is not changing. Previously, we got $100,000 for bundle A, and for bundle B, the total expenditure collapsed to 100,000. So this is the property was trying to establish all along, that irrespective of your bundle of price and quantity, total expenditure remains the same. Total expenditure never changes. And I can actually establish some mathematical proof for that statement. But before I do so, I would like to neatly summarize all these calculations on the next presentation, which is following just now. But before I depart from this part of the presentation, allow me just to make one more illustration. All right, welcome back. You might be asking, does this mean that after taking into consideration the red area, the blue area has somehow disappeared? Well, in order to strike a compromise and to make sure that this aspect does not confuse you, I would like to put a compromising color on this region where the blue area and the red area meet. So I'll shade it out as pink. You know, I used to blend blue and red in preschool to get pink. That's what I've just done on this particular portion, so that you appreciate that this is a common area for both bundle A and bundle B, right? So where your blue and red total revenue or your total expenditures meet, you've got a pink area thereof, right? There is actually an economic interpretation for this pink area, which does not make up the main part or the main focus of this production. I'll maybe have to explain it in other productions, but its definition does not hold water in this production. But just to clear out the confusion, I found necessary to put an area of compromise. So the calculations that we established from the previous slides are neatly presented as follows. So as we concluded that the total revenue or the total expenditure of a convex demand curve is constant. We also established the fact that total revenue or the total expenditure is the product between price and quantity. From the diagram, we found out that at point A or at bundle A, total revenue is the product between price and quantity. And at bundle A, our price was $1, quantity $100,000, and our total expenditure collapsed to $100,000, which is defined by the blue plus pink area. Okay, and remember the pink area that I defined later on during the production. The second point worth summarizing is that at bundle B, total revenue is the product between our price, 40 cents per kg, and 250,000 kgs. Now the product between the two gives us $100,000, being the red plus. So this is just a summary of what we developed on the previous slide, which is neatly written out for you. Now, as I suggested that it's not sufficient in itself to just conclude the finding of the total expenditure or total revenue being constant for a convex demand curve. In itself, it cannot be established. So we need to make use of some mathematical instruments or mathematical proof in order to establish that concept. I want to make use of this proof because at the end of the day, I know students might be asking, maybe he came up with some figures that justify some theorem, but actually this is a fixed mathematical property of the convex demand curve. So in order to do so, I'm going to employ the following model appearing on your screen. You might be asking me, why of all the models in mathematics, why did I choose this model to illustrate the relationship between price and quantity? Well, it's mathematically proven that when you model price and quantity, irrespective of whether you put quantity as the subject or price as the subject, it doesn't matter. But upholding the principle that the variable on the vertical axis goes onto the subject, that's just the mathematical tradition there. Right? But in economics, sometimes you can take that for granted. We can always swap quantity and price. It doesn't affect the behavior of the graph. Your numerator is a constant, showing that the numerical value on your numerator is always fixed, it never changes. Right. So suppose we're to take a numerical value for k. Say we are modeling up a relationship of price being equal to 100,000, that's 10 to the power 5, over our quantity q. Alright. And to establish whether this graph does indeed give us a convex demand curve, because you might be asking, does this model generate a convex demand curve? Well, what you have to do actually is to draw up your table of values, just like how you usually do it when you're engaging into graph work. So draw up your table of values with values of price and quantity in a corresponding fashion. Okay, so pick out your values of quantity in an ascending manner, right? And then you plug those values in turn into this model and come up with the corresponding values of price. This whole establishment has actually been done for you on some Excel presentation. So allow me to make use of the Excel illustration right here. Right, so ladies and gentlemen, appearing on your screen are some pre-established values of quantity and price, which I did in advance, okay, just to avoid wasting time. All right. So as you can see, we actually have values of price and quantity that are established within this relationship. And possibly if I was to put a value there to make sure that our graph can be modeled in the correct fashion. All right, so that was actually 100 there. But anyway, we actually have a chain of values of price and quantity running through this whole relationship. All right. You can actually type out those values for yourself using this Excel platform. Right. And after doing so, you move on to copying your values of price and quantity. Right. So after copying your values of price and quantity, you then draw out the graph for price and quantity labeled in that fashion. So as you can see, appearing on your screen is actually the convex graph that has been generated by all these values of quantity and corresponding values of price. Just in a nutshell, you can easily see that as you can divide 1,000 into 100,000 to give you 100 there, although the 100 has been occupied by some pattern there. If you divide 1,600 into 100,000, you get $62.5 and so on. So Excel actually generates a graph for you automatically. If you want to throw in a grid paper, you can choose your layout there, right? You can get rid of your trend line. And if you want to edit the graph, put some more exciting features, you can do so. So all those accessories are available in Excel. But I knew that doing all that under this presentation would waste time, so I prepared the graph in advance. So here's our graph. So appearing on your screen is actually the graph with well-defined axes. So let me just expand it for you. Right, so as you can see, appearing in your graph, it's actually a convex demand curve defined by the model price equals 100,000 over Q. So as you can see, this gives us the mathematical proof that indeed these kind of models do generate a convex demand curve. All right. So it's not like I was just cooking up some figures, but actually this has some mathematical validation. All right. And also back to Excel, before I depart from this aspect, back to Excel, if you are interested in knowing how to draw various graphs, be it on transformation or even quadratic graphs, this is another part of Gwaze tutorials, which is under the name Gwaze-Matics. So Gwaze-Matics deals with teaching you various aspects to do with mathematics, whereas Gwazonomics centers on economic issues, right? So if you want to know how to draw or generate graphs using Excel, you can always visit or consult Gwaze-Matics videos on YouTube. Right, back to our presentation as we round up. Right, let me just get rid of some of these labelings or calculations. Okay, I think I established the graphical proof for this model. Okay, but there's another part of the proof I'd like to also establish. Okay, just to show that the constant revenue for a convex demand curve is actually illustrated by this model. So to do so, I'm going to rearrange this model, and by rearranging it and making the constant the subject of the formula, we see that the constant becomes the product between price and quantity. Right, how did I rearrange this model? Well, it was just a matter of multiplying both sides by the quantity. So, right, actually that's not cancelled out, but actually it's the quantity right here. Okay, so the product between price and quantity occupies this part of the rearranged formula, and then the isolated constant occupies this part of the model. As I mentioned, K is a constant. So what does that drive home? Well, it simply tells us that the product between price and quantity of a convex demand curve is always constant. So despite the various values which price and quantity can assume, your product will never change. And remember that product actually has an economic interpretation, which is your total revenue, your total expenditure. So I've just established the fact that the total expenditure of the convex demand curve is always constant. Hence, your conclusion, thus the total revenue of a convex demand curve is constant. A famous word we might use in economics for constant is homogeneous. Thus, the total revenue of a convex demand curve is constant or homogeneous for all bundles of quantity Q and price P. Right. So that is just the mathematical validation of your constant total revenue. So not only have we proved that this model does indeed generate a convex demand curve, but we've also shown that within the same model, the total revenue is a constant character. Okay. So that brings us to the end of this production on the properties of the convex demand curve. This is the first property which I've just established in this production. The other property which I'll venture onto on the upcoming production would be to define the price elasticity of demand of the convex demand curve. And we actually prove that it is actually equal to -1. So the price elasticity of demand for a convex demand curve never changes. It is always constant at -1. I might be forced to use some calculus like differentiation. So the assumed knowledge for this production, which will follow, is that you should have some basic knowledge on differentiation, right? Even if you don't have that assumed knowledge, I'll try to build up enough background so that you won't get lost. But anyway, that's it for this production. So thank you, ladies and gentlemen, for being part and parcel of this educational broadcast. So keeping in touch, those are the WhatsApp platforms for Mr. Gwaze, that's me, and my business partner, Mr. Masia Chengu. He'll be taking on subjects such as accounting and business studies. Right. So I'll be dealing with economics and mathematics. He'll be venturing into accounting and business studies. So watch out for those videos on YouTube. And the email addresses for both of us. And till we meet, may the grace of all time be with you in Jesus' name. God bless you. And know with God all things are possible. So never, never give up, okay? Just always have the faith in you that with God you can do all things. So thank you so much, ladies and gentlemen. I'm really humbled by your cooperation. So till we meet, God bless.